Welcome to this explainer. Today we're unpacking a really fascinating case study in software architecture, looking at a company called notablackbox, or NAB. What makes them absolutely crucial to study right now is their wild origin story. See, the founders started by trying to solve how to build fully agentic, multi-tenant enterprise software at scale first, and then built the actual product after. They were completely obsessed with solving issues of agent efficiency, capability, and scalability before their platform even had a single feature. Okay, let's dive into this. It really starts with a core philosophy from NAB's founder, Bill Fisher. Now, usually, conventional startup wisdom says start small, build a garden shed, and grow over time, right? But to build a talent operating system for thousands of companies all at once, he knew that just wasn't going to cut it. Aiming absurdly big right out of the gate actually forces you to solve the hardest foundational problems on day one. So you really have to ask yourself, why would a startup voluntarily take on massive multi-tenant scaling, token efficiency, and heavy infrastructure right at the beginning? Especially when most companies are totally fine just pushing those headaches off to, version 3 or 4. Section 1. Building the skyscraper first. It really comes down to a stark contrast in how we build things. The garden shed approach is the classic playbook. Ship something simple, see what happens, and honestly, just wing the scaling part until the system breaks. But the skyscraper approach, that's the huge bet NAB made. To rebuild HR for thousands of companies simultaneously, they had to lay massive foundations. Solving multi-tenant scale, incredible token efficiency, and real infrastructure literally had to come first before they even knew what their first user feature was going to be.
Section 2. Software hostile to agents.
Let's look at why this matters so much right now. The current enterprise software world demands roughly 3.2 quadrillion tokens per month. I mean, that is a staggering number, and it's driving a projected doubling of global data center power by 2030. And on the human side, professionals are spending up to 80% of their day on pure administrative work. We absolutely need AI to take over this admin burden, but doing it the way we are right now is taking an insane environmental and financial toll. And here's exactly why. Enterprise software was originally built for a human clicking around on a screen. If you just slap an AI agent in front of that legacy software, you're basically dropping a stranger into a house designed for someone else. The AI is forced to navigate visual UIs it absolutely doesn't need. It opens unnecessary pages, it parses data shaped for web browsers, and every single wasted step burns tokens. And those tokens translate directly into real money and real electricity. The software is literally fighting the machine. So if forcing agents through these human-designed doors is the root cause of this massive energy burn, how do we actually fix it? What are the specific mechanical solutions NAB engineered to get around this? Section 3. Agents that actually do work. Let's ground this in reality. Meet Phil. He runs HR for 3 London locations of a coffee chain. Let's just call them not Starbucks. Phil comes back from holiday to 23 urgent overnight tasks. Well, NAB agents instantly triage those down to just the 6 that actually need human eyes. One store is closing, so Phil simply drags and drops to redeploy 14 staff members, and the agents draft all the transfer paperwork in the background. Later, an agent spots that a rival poached a star barista, automatically drafts a counteroffer, gets Phil's quick approval, and then the agent literally makes the phone call to the candidate. Phil clears his entire desk in under 20 minutes. He's running a desk like he's got a team of 5. Now, the only reason Phil trusts this system to do all that is because of something NAB calls the harness. Think of it like a seatbelt and a set of strict rules wrapped around the AI model. Most HR tools today, they just read data or maybe give you a little nudge. But NAB agents are given strict permissions by the user to read, write, and actually act. Updating records, firing off emails, making calls. The agents execute the boring routine legwork from start to finish, but the consequential decisions, those always rest securely with the human. Section 4. 2 doors, 1 record. Now, what's really interesting about their architecture is this patented approach to data access. They call it dual representation. It essentially means the software has 2 faces. Every single system record lives in 2 entirely different forms at the exact same time. You can think of it like 2 separate doors into the same room. The human door is the interface we're all used to. Visual screens, raw API payloads, buttons to click. But the agent door is entirely different. For the AI, the record materializes as clean code. It's an optimized file system that the model already knows how to navigate cheaply and efficiently. It performs local, projected reads directly on the disk, rather than stuffing tons of useless data into a context window. So the crucial point here is the massive difference in cost. When an AI agent tries to look up a schema table through the standard human API dump, it eats up about 6,000 tokens. But going through that native agent door, it takes roughly 400 tokens. That is a 15 times token drop for an action the agent is doing constantly all day long. This is the literal receipt that validates their crazy architectural bet to build the skyscraper foundations first.
Section 5. Leaner than the floor.
And it doesn't stop at the dual doors. NAB literally squeezes efficiency out of every corner of the architecture, in some pretty ingenious, if seemingly boring ways. They intentionally route tasks to the smallest capable model, not just the biggest one out of habit. Highly repetitive steps get compiled down into plain code to avoid running the model in expensive loops. Heavy data digging happens in cheap side windows, and routine workflows are baked into fixed, efficient tracks. The goal isn't just to use a magically smarter model. It's about engineering a highly efficient environment for the models we already have today. And this brilliantly illustrates the payoff. In pre-registered benchmarks, when you compare a generic assistant using a standard API connector versus NAB's native platform doing the exact same task, the difference is wild. NAB uses a fraction of the build tokens, a fraction of the watt hours, and a fraction of the grams of CO2 equivalent. It proves that a generic connector isn't the ceiling of AI efficiency, it's actually just the floor. When you actually run the numbers, the environmental case here is just staggering. For a single 5,000-employee enterprise running its hiring on this co-designed architecture, NAB models a massive 72% reduction in CO2 equivalent every single year. So what looks like a rounding error for one company compounds into a huge drop in real carbon emissions across a fleet of thousands of tenants. But we do have to talk about an uncomfortable truth here, Jevons paradox. It's this well-known economic idea that making a resource cheaper and more efficient can actually lead to a huge increase in its total consumption simply because it's easier to use. NABFab doesn't hide from this at all. In fact, they tackle it head-on by putting a live carbon meter directly on every single user's screen. Because at the end of the day, you literally cannot manage what you don't measure. And I think that philosophy is perfectly summed up by a quote from their green compute brief. Tokens per watt is the challenge. Tokens per outcome is the answer. A model that is incredibly efficient per token, but takes 10 times the steps to do a job, is basically useless. By co-designing the agent and the actual software it lives inside, you ensure that the cost per outcome falls dramatically. And really, that is the true metric of success for enterprise AI. Which leaves us with this final thought. We are entering an era of massive global AI adoption. The models themselves are extraordinary, but the software we force them to use is just full of friction. So are we going to keep accepting the staggering environmental and financial costs of forcing agents through human doors? Or will we follow this blueprint, tackle the unglamorous problems of scale and token efficiency on day one, and finally build the skyscraper? Thanks for joining me for this explainer. I really hope this leaves you with plenty to think about.